In this video, we're integrating e to the 2x times the square root of 1 minus e to the 2x. And we're going to handle this first in an informal way, just recognizing how the chain rule works backwards. And then we'll verify that solution is correct by doing an explicit u-substitution. So to recognize the chain rule working backwards, what we do is recognize that we're looking at a composite function that's 1 minus e to the 2x, all square rooted, sitting right next to the derivative of the interior of that composite function. Now, e to the 2x is not exactly the derivative of the interior. The derivative of the interior is a negative e to the 2x multiplied by 2. And that's the chain rule operating on that exponent of 2x. So what I want to get in the interior is a negative 2 e to the 2x sitting right next to this composite function. And I'm going to go ahead and write the composite function as a fractional power now because we're about to use the power rule for antiderivatives. And so I just threw a negative 2 inside the integral so I'd have the exact derivative in the integrand. And of course, you can't get away with that. You have to multiply by negative 1/2 out in front to compensate for that negative 2. And with the derivative of the interior sitting right there, the results of the chain rule are already taken care of. And all I have to do is use the power rule on this composite function, add 1 to the exponent, 1 minus e to the 2x to the 3/2, and then divide by that resulting exponent. So divide by 3/2. And it's indefinite, so I have a plus c here. So now just as a quick mental check, if I imagine differentiating this piece, I would bring down the factor of 3/2, canceling the 3/2 in the denominator, subtract 1 from that exponent, giving me a 1/2 as an exponent. And then the chain rule says you have to multiply by the derivative of the interior, which again is negative 2 e to the 2x. And so that would get me back to the integrand I had in the previous step. So we've successfully done the chain rule backwards here, and we can just clean things up a little. Dividing by 3/2 is the same as multiplying by 2/3, and then the 2's are going to cancel. And I end up with a negative 1/3 times the quantity 1 minus e to the 2x to the 3/2 plus c, and we're done. Now the formal approach to this problem is to do an explicit u-substitution. So we're going to say let u equal the interior of that composite function, 1 minus e to the 2x. And then the derivative of that is negative 2 e to the 2x. So du is going to be negative 2 e to the 2x dx. Now again, none of this works unless we're lucky enough to have the derivative of the interior function essentially sitting there in the integrand right next to this composite function. That's the only thing that allows you to do the chain rule backwards. So if you aren't seeing that things are set up correctly, you shouldn't expect a u-substitution to work in the first place. So now that I get to this point, there's a couple different approaches to the next step. I could construct du in the integrand by multiplying the interior by negative 2 and then multiplying by negative 1/2 out in front. But I've really already done that once, and so I want to show the other way to do it, and that's explicitly subbing in for dx. And so dx in this case is du over negative 2 e to the 2x. I know some students prefer to do it this way. So I start transforming my integral, and I have an e to the 2x out in front, and then I have a square root of this 1 minus e to the 2x, but that's just u, so I'm going to write it as square root u, and then dx can be replaced with du over negative 2 e to the 2x. Now again, this doesn't work unless you have the right functional piece out there in front to give you the derivative of the interior function. That's why our x dependence cancels out at this point, and I end up with a negative 1/2 just pulling that out in front. And the integral is the square root of u, which I'll write as u to the 1/2 times du. And so I have negative 1/2 u to the 3/2 over 3/2. Again, those 2's cancel, and I get a negative 1/3 u to the 3/2. And I'll throw in my plus c at this point. And then I still have to sub in what u was in terms of x. So negative 1/3, 1 minus e to the 2x to the 3/2 plus c, and we get to the same place. If you enjoyed this video or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.